let me discuss about the Intel 8051 microcontroller. Micro means small size, controller means it is basically going to be used for control function, industry especially. So in 1981, Intel introduced an 8-bit microcontroller it is called as an 805 microcontroller. This is one of the basic type of microcontroller. It is based on the Harvard architecture. We have two architecture, one Newman and Harvard architecture. It is a Harvard architecture. It is basically used to in embedded systems. Embedded means any device it is having hardware and software. It is designed for particular function, for specific function. For example, your micro oven or refrigerator, washing machine, digital camera. These are all examples of an embedded system. So Intel designed this 8051 using CMOS technology, that is complementary metal oxide semiconductor technology. So it requires less power. That is the reason they are going to use CMOS technology instead of BJT, instead of TTL, transistor logic. Then usually they are going to specify the names. Practically, if you are going to use 8051 microcontroller family, they'll have specific numbers, so you can able to understand. For example, if it is AT89C51 is nothing but first two letters for the company name, that is AT stands for Atmel, then C stands for CMOS technology, and 51 stands for it is a 8051 family. Then 89 is a flash type memory. So that is the meaning for each letter. So now let us see a few the naming conventions used for 8051 family, like ROM type. Only if it is a ROM memory, I mean ROM, different ROM type, like how they are going to specify. 8031 no ROM. So 80, if it start with 80, there is a mask ROM will be there. 87 means it is a EPROM. If it is 89 means flash type ROM will be there. EPROM, flash type EPROM. Now let us see 89 series. These are all 89 series. So this is a 51, 52. 52 means it is a 3 timers. Okay, like different. Then we have few examples as I told you. Here how they are going to specify the name. First two letters for the manufacturer. Then after that, these 2 digits for which type of memory used. Then C stands for technology. Here C is CMOS technology. Then 51 is a 51 family, 805 family. So like this, each is having a different ROM, RAM, timer, and interrupt source, and IO pins, and other special inbuilt peripheral like watchdog timer, then analog comparator, then in system programmable. These are all different features. Now let us look at about the block diagram of the 8051 microcontroller. It's very important. See here, it gives you what are the contents of the 8051 microcontroller. It consists of all these blocks, whatever you mentioned. These are all available in one single IC. These are all available in a single IC, in one IC, in one chip. So here the main is CPU, central processing unit. It consists of ALU, arithmetic logic unit, and also having the control unit and few registers. Then we have oscillator here. It is going to generate the clock. So for every operations here, synchronize with the clock. Then we have bus control device is going to control the buses. Then we have 4 kilobyte of ROM. This is a basic device. Will have minimum 4 KB of ROM. You can have more RAM also with the different versions. Then 128 bytes of RAM. So the RAM temporary memory, ROM is a permanent memory. Your program is going to store, your data is going to store. Then we have two timers, timer 0, timer 1. And these timers also will be used as a counter. Then we have IO ports, 4 IO ports, port 0, port 1, port 2, port 3. Total 4 IO ports. Any IO devices can be connected to these ports. Then we have one serial port to send the data from controller to any other device in serial form, bit by bit. At a time, 1 bit can be transferred through using TXD line, and also you can receive the bit in serial form through receiver line. Then we have the interrupt control. Interrupt control is one. It's going to take care of which interrupt to be considered first. And is it maskable or non-maskable? That all will be see that depending upon their types of interrupts. Is it a vector? Is it a non-vector? Is it a maskable, non-maskable? So all the going to check the interrupt controller, and according to that, it is going to send the signal to the processor. Once interrupt occurs, the process stop its current execution, then provide the service to the interrupted device. So these all the main components of the 8051 microcontroller. Now let me see in detail about this internal structure. Here just a block diagram here, little bit brief about the internal architecture. Architecture is nothing but how data is going to flow from one device to another device. That is called architecture. Here you can see in detail there is ALU there, as we showed there CPU. Inside CPU there is ALU. Then temp 1 and temp 2, these are the storage devices. The ALU is going to operate on two data. So one data always in accumulator, other it may be a register or memory. It will brought to this temp location. Then the ALU will be performed as specified. It may be arithmetic or logical operations. After performing its operation, depend upon the result, the status will be reflected in the flag bits, and the result, whatever is going to get after performing addition or subtraction or multiplication, division, that result is going to store once again into the accumulator. Okay. So now we have register B, another one. So this register B is a special function like in multiplication, division. So one of the operand should be register B. Then we have, as I shown you, oscillator, as I told you, is going to generate the clock. This is our control unit. And we have ports, port 0, port 1, port 2, port 3. Is having latch for storage and drivers to increase the current capacity of the IO pins, so that those IO pins will be connected to the external devices. Then we have RAM memory for storing the data temporarily during the execution of the program. The RAM address register there. For RAM also will have address. That address will be stored in RAM address register. Then we have ROM for storing the program. The program is stored in this ROM memory. So it is also have the address, program address register. It shows the address of the ROM memory. Then we have buffer for storing the from external. If it comes, first it stores the buffer. Then you have program counter incrementer. As you know, that program counter is going to hold the address of the instruction to be executed. Then program counter. Here, program counter and program incrementer. Internal is going to increment. And DPTR is also a pointer. It is going to hold the address of the data. Address of the data. So this is the overall architecture of the 8051 microcontroller.